Alright, I laid down some video last night, which I really didn't even get to where I was going with anything. Partly because I didn't want to get there too fast. I'm kind of not sure about what I found here, and also my computer started bugging out, and it stopped working. So here we are the next day, Friday, in the afternoon, well, late morning, and I thought I'd just talk about what I found on the moon on the near side when I did a little simple imagery analysis recently, so we can get back into that. Basically, I downloaded imagery, as I've said in the other videos, and took a look at it and found this, basically. So the first thing that's interesting is that this is pretty close to real color. So when I started looking at this, I thought to myself, you know, if it's real color, then there's going to be similarities between colors you see on the moon and colors you'd see on Earth. And so if you start with real basic image analysis, you look at stuff that's white, and you know simply that it's a brighter object. That's the obvious reason it's white and bright. And similarly, you look at areas that are very dark, and they're low in reflectivity. They don't return a lot of light. Once light hits that surface, whatever it is that's black, it's absorbed, not returned, so it looks black. Additionally, you could potentially, if you were doing image analysis before you release this photo, you could take particular areas and blacken them, you know, remove or change the information so that whatever it is, it appears blacker, so it's not as obvious what it is. So okay, so we have bright stuff and we have dark stuff, and we have stuff with some color to it. So let's talk about the bright stuff. Typically these are going to also correlate to high points, tops of mountains, tops of landmass, you know, and probably it's the topmost point. A lot of these white areas seem to appear in the middle of a bigger circular area, and you could picture it being the peak of a mound of Earth. Well, you wouldn't call it Earth, a mound of moon. So that's, you know, probably what that is. It's the most simple and direct way to interpret it. Now, why is it white? What material is that? I don't know myself. It's likely to be a very bright material relative to the other stuff around it, and potentially if it's at the top of structures, it's a hard, durable material. It wouldn't be like something that would easily be removed from the top of a mountain. Even though the moon doesn't have wind and such, it may have had things in the past which would at least disturb the you know, stuff piled up on the top of a peak of a hillside or a mountain, and leave only what's durable and hard and not easily removed. And apparently that's often bright white. So that's, you know, some of that analysis of what the white points are and what they may represent. And similarly, the dark areas are typically going to be your lower elevations. They're going to be the valleys and the depressions and the shadows behind tall things as well. So if you have something really tall, like maybe down here, you can see these little black edges are probably shadows of a taller thing, so that would indicate the sun is coming from the bottom of the image and the shadows being cast towards the top. Now my guess is the shadows are not reliable directional indicators for the light source, due to the fact that they probably had an instrument that was sampling this imagery, this entire data set, over different days and times. So shadows may be cast in one direction at one time they gathered imagery, in another direction the next time, but they're putting all this imagery together. So I would expect that the shadows aren't consistently in the same direction across the imagery. Again, I haven't really looked into what the sensor was that gathered this, how it was gathered. I don't know the technical side, so I mean, I've done that, I understand it, but in this case I haven't looked at that at all. I don't know who processed the imagery and what they did to it, nothing. All I know is they gave this to the public, and I'm the public, so I took a look at it. And the dark stuff struck me because it's very dark in here, and it's very dark around this colored area. If we zoom out, I mean, this is the whole thing here, so you can see there are areas where it is just apparently quite barren. It's, you know, no color, no real features, and then you get an area like this, which is kind of the opposite. A lot of different features and colors. And one thing I noticed, and this will be something you can see throughout the moon imagery, is if you take one of these areas that's bright white at the top of what looks like a tall mountain or something of that nature, you see these lines running away from the center of the mountain like spokes or like pathways. So it excuse me, it looks like paths to me. It looks like something on the surface that would move across the same area in the same direction back and forth repeatedly over a long period of time and create pathways. So we'll keep that in mind as we look at some of this. It could be that there's something in the past or something currently that is traveling in directional lines between structures, and they often seem to go to these big features. So what is that? I don't know. I don't know what causes it. I'm observing it, and it's kind of interesting. I'm also observing some artifacts in the data, or some stuff that does not look right. It looks like it's a glitch, like right here, this line. If we go to full resolution there, you'll see what I'm talking about. This kind of stuff right here. It's like a rectangle. Here's a little one, here's another one, here's another one, another one. From an image analyst standpoint, I'd say there's a fair likelihood that this is just when the sensor was malfunctioning or the data was compromised in some way. I don't know that. That's just, it makes sense to me that you can get those effects when the sensor's misbehaving. Here's probably an example of when the mosaic of the imagery reveals some edge effects, boundary effects, like this here. You can see this line. What that probably is just a little different calibration or different values that are being returned from the sensor in this pass versus this, and although they try and normalize it all and make it look the same, it doesn't always do that when you do the image processing. So you eventually or occasionally, when you're collecting data, you get stuff like this, which is interesting because you can kind of see the stuff behind it is coming through. It's not blacked out. You can tell the general colors and the lines sort of agree with the features, which you can see well. So to me it looks like bad data. It could be somebody that has a method to paint out parts of the scene they don't want you to see, but it's so regular and so square or rectangular that you know, my guess, probably just bad data. I don't know. We'll leave it at that for now, because that's not why I'm even talking about this. I'm still rambling my way into what I am seeing. Some of you may have started to think about this. One thing I've found is features like this. Now, what is that? It sure looks like a groove, a meandering line, which is often a river here on Earth. I mean, that sure has the characteristics. As a natural formation, something had to cause that. As an unnatural formation, something had to cause that. And that would be other life. I'd say it's probably a natural formation that, for whatever reason, looks a lot like a river. So let's look at some more. So now that we've been looking at this just a little bit, everyone is aware that this is kind of real color. It's true color, or close to true. And so what are we seeing here? I mean, okay, what color is this? It sure looks green to me. Now I've said it. It looks green, right? That looks green. And the data confirms that. If you go up and look at the info, which I explained in the previous video, you can get the red, green, and blue values here, and you can get the cyan, magenta, yellow, and black values here. Most people don't really conceptualize cyan, magenta, and yellow. You can do that very effectively for printing colored materials on paper, and I've done that, but it doesn't make intuitive sense to the same extent that red, green, and blue does. So we'll look at red, green, and blue, and then K is useful here in the CMYK because it tells you how black something is. So if you keep an eye on that K, I'll go find a very white thing like this here, and that K says 0 now. Well, let's do something next so you can see the K and the, there it is. K is 0, right? So no black. And then if you see the R, G, and B are all in the 200s there, so the values are equal. It's equally red, green, and blue at the same time, which makes white. That confirms, you know, it makes sense. It is what you would expect. So now let's look at really what the crux of this biscuit is, and that's this green stuff. Now keep an eye on the G there. G in red, pretty big, right? Now look at the G, still going up. G's really high there. So you got like here, there we go. Let's look at the red, green, and blue. Red 36, green 67, so that's almost twice as much green as red and not much blue. So there you have it. I mean, here on Earth, when you discover a lot of green stuff, you're more often than not talking about plants, are we not? I mean, isn't that what's green here on Earth for the most part? So what's all this green stuff on the moon? What's all this green stuff on the moon? I don't know, but there it is. It's green. So my explanation, if I just did the Occam's razor approach, would be that well, green, it means plants. So maybe not. There's other stuff that's green in this universe, and could be patches of green things on the moon. I don't know. Never been there. This is my closest look. Now, having said that, you know, you can see for yourself if you keep an eye on these values. Move it over here. Keep an eye on these informational values here, and you know, there's just a lot of green. You can see there. It's 20 in the red, 40 in the green, so twice as strong. Lots of green. And now, of course, somebody has probably noticed by now that there's also these cyan and blue colors all over the place. Cyan being the light blue kind of thing. It's represented by the C here. Cyan, magenta, yellow, and black. So if we look at blue things, or look for blue things, you can keep an eye on this B, and you can keep an eye on this C. And again, to relate it to Earth, obviously, the blue things here on Earth are the water elements. I mean, the sky's blue, but if you're looking down on the Earth from above, like we're looking down on the moon from above, and you see a lot of blue stuff here on Earth, it's more often than not water, almost all the time, really. And correlating the water idea to the rest of the imagery, well, what is often the white stuff at the top of mountains? You know, that's snow, right? I mean, here on Earth, it can remain a long time, and it's very bright white, reflects a lot of light, and that's what we see in some of this white stuff. If you go to the very white things, and you know, that's a lot of reflected light. So snow and ice can do that. Don't know if that's what it is. Don't know, but that's possible, right? I mean, so keep an open mind. Now, if we're looking at blue stuff, this looks very blue to me. Oh, now keep an eye on these numbers. It is. You can see the blue is 63 and the green over here. The blue 60, green 40, blue 70. Not much red. Now that's another interesting thing about if you're looking for water. The not much red part would indicate that the red has gone away. It didn't return. The light hit it, it had red in it, and it reflected back without. That's typical of water, except when there's glint off the surface, which then can be bright and have some red in it. But typically, if you're looking into the water, the first thing that goes away is red, and divers know this. If you go not even that deep into the water column, red starts to look black. It doesn't have any red left because there's no red in the electromagnetic spectrum underwater at that point. Unless you introduced artificial lights for photography or video, you don't see red. So an indication of water is not only that it shows up with a lot of blue, it shows up with very little red simultaneously. And that's an interesting feature, even in these very, very black areas. See, this is indicative to me of potentially just zeroing out the data, because here we have red, green, and blue are almost all zeros. Well, that's pretty much no information. There's nothing there in this image where, you know, it's just all zeros where the black is. Well, if you're collecting data, you know, if you've spent all this time, effort, money, and everything to get to the moon and analyze imagery that you collected there, you don't really want zeros in your data. That's possibly going to happen if things don't work out, but it's you're not meeting your objectives when that occurs. So it may be that if this was water, let's just say hypothetically, if this is water and they were working to make it not as obvious, you could do what's appearing to be done here, which is zeroing it out in a lot of areas, making it just black. What is black? Well, who knows? You know, if there's no information there, can't really say. But where there is some is in these areas that seem to come up out of the, you know, have higher elevations. They're not as depressed, and so there's blue there. So now maybe we're seeing shallow seas around higher areas. If it was water, I'm not saying I know that it is, but the other thing that's interesting, of course, is what happens on Earth. You see areas full of water where there's areas full of vegetation, right? And that's exactly what we're seeing here. If that green is vegetation and the blue is water, well, that's peanut butter and jelly here on Earth, right? I mean, you got to have the water for the plants to flourish. And so who knows? It's possible. That's all I'm saying. And now we can look at some of these other areas that have what I see as very light blue. And again, if you keep your eye on the information here, if I go to something like light blue, you can see the C in the CMYK, cyan is 79%. So that's pretty light blue. That's just like it looks like. And I've noticed that the light blue is correlating to a lot of little dots in the landscape, and then sometimes rims around these circular structure. Like you'll have the interior circle looks kind of grayish, or you know, more or less grayish, and then it's got a ring around it that's whitish and cyan bluish. So what is that? Don't know. I don't know what cyan correlates to up there on the moon, and why it would be circular and why it would be bright. It's almost like it's got light coming from it, and that might be a possibility if you had artificial lights that had a cyan tint to them, and that was one of the main ways you had lights up there on the moon, assuming there was colonies of living things, either humanoid or others. Then yeah, you could see this where you'd have all these little dots of light, and then in the bigger developed areas where there's a bigger settlement of people or whatever may be there, then you get these bigger, brighter cyan circles. but they're kind of everywhere in some areas where there's green stuff and watery looking stuff. And then if you go over into the washed out gray areas of the moon, you don't really see that. I don't see any cyan or light blue. I don't see any green. I don't see any blue. So interesting there too. And then you get a feature like this. I mean, that's got a real blue to it there. For whatever reason, don't know. So right now we're looking at what I think of as kind of a mystery. And you get into this area again. This is very, very dark, 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 dark. 0, 0, 0, zeros. But then around areas which may be getting shallower, extremely blue. I mean, it looks blue here because it is blue. You know, there's some green. Green, blue, green, blue, green, blue. Interesting. I know what that would be on Earth, but we're on the moon. So, I guess that's something to think about. I'll leave it at that. It's not proving anything by any means, and partly the reason to share it is to see what other people think. I mean, this is about kindergarten level image analysis, and it's using the most basic and simple tools and reasoning, and nonetheless, why is there so much blue and green here in this section of the moon, and what is blue and green? What is that color? Why is it that color? Why are they together? And what are those cyan little dots and circles everywhere? I will point out one other thing, and then I'm going to end this video. As you look across the moonscape, you're going to see circular things like this on different scales all over the place. So you have a dark area in the middle and a bright white area around it, and then whatever the landscape is. And you'll see one here, a little smaller, much smaller, but you can see there's a little dot in the middle and a little ring around it, and there's a bigger one, a different size one that's not as dark in the middle, another one. And even if you go out in the gray areas, you're going to see some of that same circular pattern, dark circle in the middle, bright around it. Just keep an eye out for that, because that's everywhere. And certainly you can see craters all over the place. This looks like a classic crater to me, where it's dark in the middle, and that would be the low point where the crater hit, and then when it threw stuff up in a circle around it, that could be the bright spot. So, you know, these have a lot of crater type of features. And then again, you get one like this where it doesn't quite fit that pattern. It's got a bright spot right in the middle, a dark circle here, and then bright again, and then it's got this little notch in it. So, and of course the tendency is to think, well, I'll just zoom in and look closer, but this is pixel for pixel representation. Now if I zoom in, which I can do, it's going to start to pixelate. So now we're starting to lose a a little bit of data, or a little, yeah, I mean a little interpretation on the computer's part here, but you can still see the features. But you can also see it's just started to pixelate, and here again is the real scale. Not zoomed in past where the pixels are real pixels. Okay, well, I've said what I have to say on that one. I'll think about it some more and maybe come back at this and say a little more, but essentially I've gotten to the point where I've shared the discovery, the green and the blue. The green and the blue, the green and the blue. What is that? What does it represent? How is it on the moon? I've looked at that my whole life. It always had a certain tinge of, you know, you can see that dark spot on the moon from just looking outside at night, and it always looked kind of a blue-gray, you know, dark blackish, grayish, not too blue, but it might have had a little, hard to say. But now that I'm looking at it this way, the evidence is there, so we'll pick it up later.